All right, welcome for this basically a review lesson on graphing functions. So today we're going to be talking about graphing functions. We're going to be graphing functions. We've already learned this. We know how to graph functions using tables, and that's what we're focusing on. And we also know how to graph functions using slope and y-intercept a little bit. Today, I'm not giving you your actual notes. So you're going to have to write these on a separate sheet of paper, so please go ahead and take a separate sheet of paper out. Write 3.4 on the upper right hand corner of your paper. That's the section that pertains to this unit. And again, this will just be a review. We're kind of combining multiple lessons into one here. So graphing functions, we've done that already. We've graphed using a domain, using a table. And we're also combining, especially with this problem, something that we learned a few weeks ago, which was literal equations and manipulating equations to solve for a specific variable. So why would we need to do that with this equation? Well, if you remember, y is your range, it's your output. And typically, when we've been graphing these functions, it's always been y equals something. Y is always by itself. And it's a lot easier to plug in your domains, your x's, if you have your equation or your function in the form of y equals something. Okay, and that's why in this case it's beneficial for us to go ahead and solve for y. Get everything else on the right hand side. And that's what we're going to do first. So just like we did a few lessons ago, we're going to move everything to the right hand side and leave y by itself. So first thing we're going to do is subtract by x. Now you can't actually subtract 15 and x, so that would just be, we'll do some blue, 3y equals negative x plus 15. Okay, can't actually do negative x plus 15, so you'd have to leave it like that. So what we'd do next, again, you're trying to get y by itself, so you divide by 3 on both sides. Okay, and if you do that, you're left with, let me get blue, y equals negative x plus 15 over 3. And I want to make it as easy as possible for me to plug in these domains and get my outputs. I want to make it as easy as possible for me to find my range given these domains. So I'm going to manipulate this equation a bit more. So if we know that it's negative x plus 15 divided by 3, then we could just change this to y equals negative x over 3 plus 15 over 3, right? Because that 3 is being, we're dividing negative x by 3 and 15 by 3, okay? And why would I want to do this? Would make it a little bit easier to plug in our domains later on, because now what this turns into, and I'll write it up here, I'll just put an arrow here. So what this would turn into is y equals, well, your first term there would just be negative 1/3 x. Okay, now this term over here though, 15 over 3, we can simplify that and that would just be plus 5. So it makes it a bit easier to go ahead and plug in our domains in just a moment if we rewrite it in this way. And this would actually be slope-intercept form, right? You guys know that already. That's in y equals mx plus b. We're not going to graph this using our y-intercept and our slope, but it's interesting to note that this is slope-intercept form. So now let's go ahead and take a look at our table. So they want us to graph this function given a specific set of domains, okay? And the specific set of domains is 0, 3, 6, and 9. And we know how to do this already. We have our equation right here. So all we would need to do is plug in our domains to figure out our range. Plug in our x to figure out our y. So first one, our first domain is 0. We plug in 0. Well, negative 1/3 times 0 is just 0. And plus 5, that would just equal 5. So our first ordered pair would be 0, 5. Next, plugging in 3. Well, 3 times negative 1/3 is negative 1. And negative 1 plus 5 would be 4. So your second ordered pair, our domain, our x value would be 3, and then our y would be 4. Same with the next one. We have 6 So we plug in 6, negative 1/3 times 6 is negative 2, and negative 2 plus 5 is 3. So our third range would be, a range value would be 3, so our third ordered pair would be 6, 3. And then finally, we have 9, our last domain, so we plug in 9 for x, and we would get negative 1/3 times 9 is negative 3. Negative 3 plus 5 is 2. So our last ordered pair would be 9, 2. Okay, and this is again just what we've been doing already. This is just what we've been doing so far with tables, and now we would just graph it. And I'm sorry, my dogs are barking. I want you to be very careful about this, because they want you to graph the specific domains that they were talking about. And I gave some of you half credit for this on your last test, but they're not asking you to create a line. They're wanting this to be a discrete graph. Okay, and I'll explain a bit more on that in just a moment. So our first ordered pair is going to be 0, 5, which is going to be right here. 0, 5. Okay, our second ordered pair is going to be 3, 4, which is going to be right here. Our third ordered pair is 6, 3, which is going to be right here. And our last ordered pair is 9, 2, which will be right here. Now, that's it. You just leave these as points. Do not connect them with lines. Okay? They just wanted us to graph these specific domains and ranges, these specific ordered pairs. Now, what happens if you connect these with a line? Then you're giving me an infinite amount of solutions. Okay? And yes, this is a linear equation, and yes, this would have an infinite amount of solutions, but not for those given domains. For those given domains, there's just a specific set of ranges, so we only want those specific ordered pairs, those specific points. So this would be a discrete graph, not continuous. We're not going to connect this with a line. We just leave it like this. Let's take a look at this one next. Y equals negative x squared. So this one is already in the form of y equals something. We don't need to solve for y. Y is already by itself. So this one we just create a table. Okay, we just create a table. So we'd have our table with our domains, our function, or our equation, which would be y equals negative x squared, and then our range y. And now, just like we did before, we would just plug in random points. Okay, so we might want to plug in negative 2, negative 1, 0, 1, and 2. Okay, so we plug in these random domains. Okay, and this says graph each function. It's not telling us to graph for a specific set of domains. So in this case, we would connect these with a curve or a line. In this case, it's going to be a curve. So let's go ahead and solve these. So this would be y equals negative, and then negative 2 squared. So negative 2 squared is positive 4, right? But then we have this negative on the outside that would make it a negative 4. Okay, then we have y equals negative 1 squared. Again, negative 1 squared is 1, right? But then we have this negative on the outside here that would make it negative 1. Then y equals negative 0 squared would obviously just be 0. Y equals negative 1 squared would be negative 1. Y equals negative 2 squared would be just a negative 4. Okay, and I forgot to put a spot for ordered pairs, but let's go ahead and do our ordered pairs. So our first ordered pair would be negative 2 comma negative 4. And we'd have negative 1 comma negative 1, 0, 0, 1, negative 1, and 2, negative 4. Now we just plot them, and I'll use blue. So our first ordered pair would be negative 2, negative 4, which would be right here. Then we'd have negative 1, negative 1, which would be somewhere in the middle here. Then we have 0, 0, 1, 1, into -4. In this case, we weren't graphing specific domains, so we would just go ahead and connect these with a curve here. There we go. It'll be a parabola, and that's it. That's all you would have to do. So just plug in random x's, plug in random domains, find your range, and plot the points on a graph. Alright, so here we're asked to use a graph to find the value of f of x when x equals 3. Okay, we would just do the same thing we've done already. So we would just create a table, x, then your function was going to be f of x equals -x plus 7, and then your range, and hopefully we have space for some word pairs here. Okay, and then we just plug in random domains to figure out the ranges. So I'm going to go ahead and use 0, 1, 2, and 4. I'm skipping 3 because 3 would just, I mean, you could use 3, that would give you your answer right away. But we want to figure out what our range is at x equals 3 by using the graph instead of just by plugging it into our function. But you could just as easily just plug in 3 into your function, and that would also give you your answer. So first, f of 0 would be just 0 plus 7, right? So f of 0 would be 0 plus 7, which would be 7. So your first ordered pair would be 0, 7, okay? Which would be right over here. Oh, that's horrible. Okay, 0, 7. Then next we'd have -1 plus 7 if we plug in 1 into our function. So that would just be 6. So your second ordered pair would be 1, 6, which would be right here. Okay. Then your next ordered pair would be, if we plug in 2, so that would be -2 plus 7, which is 5. So it would be 2, 5, which would be somewhere around here. Next you have 4, so that would just be -4 plus 7, which would be 3. Okay, so 4, 3, because we skipped 3, and then we would just draw a line here. Ooh, that's horrible. That is a horrible line. I'm sorry. Okay, so we want to try to figure out what our range is when x equals 3. So how would I do that? Well, I'd look for x on our x-axis, and we're looking at 3, which would be right here. And you just draw like we did before. Draw a vertical line till we get to that y. Till we get to our line, I'm sorry, and then we look at the value on the y-axis using a horizontal line. And if you do that, you see that when x equals 3, using our graph, using our line, when f of x is 3, our y is going to be 4. Okay, that's how you do it. So it's similar to what we've done before. We did this a couple days ago. So that's all you would need to do. And that's where we're gonna stop for today. So hopefully this was just mostly just a review for you all. Right now, what I want you to do is just get onto your online textbook. You're gonna have an assignment waiting for you. Complete that assignment and complete. Some of you have missing assignments that you haven't done, so make sure you complete those assignments as well. And I will hopefully be back tomorrow. I'm sorry that I've missed the last couple of days, but you will have a test tomorrow on all this material, so make sure you study your notes, and make sure you also complete all your homework assignments and finish your Delta Math, because all of that's going to be turned in and collected tomorrow, and you will have that test tomorrow, so be prepared. All right, I hope you have a great day, and hopefully I will see you tomorrow.